In this example, we want to find sine of a plus b, given sine of a equals negative 1/4 and cosine b equals 1/3, with a and b being angles that are both in quadrant 4. The first thing that we need to do when approaching a sum or difference identity is to write out the identity so we know exactly what we're searching for. In this case, sine of a plus b has an identity that's equal to sine of a times cosine of b plus cosine a times sine of b. Now that we have those, we know that we are looking for cosine A and sine of B, since we were already given sine of A and cosine of B. So we're going to go ahead and plug in our known values. Again, we said sine of A is negative 1/4, and cosine of B is positive 1/3, plus cosine A we don't know, and sine of B we do not know. So we can go ahead and start by finding cosine of A, then sine of B, plugging them into this formula, and then just simplifying. So to start off with, cosine of A, the way that we're going to find it is we know one of our biggest identities, one of our Pythagorean identities, is that sine squared A plus cosine squared A is equal to 1. So no matter what angle A we pick, if we square sine of that angle plus squaring cosine of that angle, we will get a value of 1, which means if we plug in this negative 1/4 for sine of A, we'll get negative 1/4 quantity squared instead of sine squared A plus cosine squared A is equal to 1. And now we just want to start solving for cosine squared A. So first of all, negative 1/4 squared means negative 1/4 times negative 1/4. That gives us positive 1/16 plus cosine squared A equals 1. And now we can subtract 1/16 from each side of the equation, which gives us cosine squared A is equal to 1 minus 1/16 is the same thing as 16 over 16 minus 1/16. Whenever you have 1, it's the same thing as any number over itself. So 16 minus 1 over 16 gives us 15/16. And now to finally get cosine of A by itself, we're going to take the square root of each side, leaving us with cosine of A equals plus or minus, because we took the square root of each side, the square root of 15 over the square root of 16. Remember, whenever you have a square root of a fraction, you can just split the square root over the top and bottom. And this allows us to simplify. The square root of 15 over the square root of 16 just leaves us with the square root of 15 over 4. And now the last thing we have to decide is whether it's positive or negative. So because we said angle A is in quadrant 4 cosine is positive, so we'll finally say cosine of A equals the positive square root of 15 over 4. which gives us our first trig function value that we were looking for. Now we can look for the second one, sine of b. And we're going to do the exact same process. So in this case, we get cosine of b, or cosine squared b, plus sine squared b is equal to 1. That's just our standard Pythagorean identity. We can plug in cosine b to get the quantity of 1/3 squared plus sine squared b is equal to 1. From here, 1/3 squared is 1/3 times 1/3. That just gives us 1/9 plus sine squared b equals 1. And now to get sine squared b alone, we will subtract 1/9 from each side, which gives us sine squared b equals, and now going right back to what we did over here with the 16 denominator, we now have a denominator of 9, which means 1 minus 1/9 is the same thing as 9/9 minus 1/9. Again, 1 is the same thing as any number over itself. So 9 minus 1/9 leaves us with 8/9. And now we can finally get sine of b by itself by taking the square root of each side, leaving us with sine of b equals plus or minus the square root of 8 over the square root of 9. And there are a couple of things we can simplify here. We have a plus or minus. Starting with the bottom, that's the easier of the two. The square root of 9 is just 3. But the square root of 8 is a little trickier. So I'm going to write this in the bottom right corner. The square root of 8 is the same thing as the square root of 4 times the square root of 2. And we can take the square root of 4 and evaluate it to get 2, which leaves us with 2 times the square root of 2 is the same thing as the square root of 8. So we get 2 root 2 in our numerator. And finally, because we said angle B is in quadrant 4, that means sine of that angle will be negative. So sine of b is equal to the negative 2 times the root 2 over 3. So going back up to what we had over here, sine of a plus b equals negative 1/4 times 1/3 plus cosine a times sine of b. We can now plug in cosine a and sine of b, which gives us, we can go ahead and simplify this fraction when we do it, negative 1/12 plus cosine of a, we said was the square root of 15 over 4, times sine of b, we said was negative 2 root 2 over 3. So we're left with negative 1/12, and now we can multiply these fractions straight across just like we did with these last two. So we get the square root of 15 times negative 2 root 2. We're just going to end up getting minus, because of the negative, 2 times the square root of 15 times 2 is 30. The square root of 30 does not simplify, that's why we just left it like this. Divided by 4 times 3 is 12. And now for our last step, we want to combine this into one fraction. Since we have a common denominator, we can do so. leaving us with -1 minus 2 root 30 all over 12. And that is the value of sine of A plus B.